Hey guys, let's go to problem 25. So what is this asking us? Well, I wrote down on the think through that we need to find out the, like the minimum value of rational expressions that can only be found using AMGM inequality. It's not really only, but mostly it can be found using AMGM inequality. So we got 25. So let me write 25 out here. So we got some x squared. I got some x squared plus x minus 1 divided out by x minus 1. All right, so I need to find the minimum value of this. And I don't need to find the explicit x value, but apparently the minimum value for x greater than 1, I would say, will occur at certain value n. I don't know, like how do we find it? Oh, we're just going to give it a try using this one. Remember AMGM inequality. So if you recall how to perform AM and GM inequality, so GM inequality, you should remember that we got some A, real number B, and probably it's going to be best if we have, the positive reals. This is going to be greater than or equal to radical A times B. Well, that's a classic AMGM inequality, right? This is going to be the arithmetic mean, and that's going to be the geometric mean. And you can understand that the summation has to be greater than or equal to 2 times square root of A times B. And we're going to use this, okay? We're going to use this, but we can use it directly. So I'm going to perform long division, okay? So step 1. So I will say step 1. So step 1, perform long division, because this hasn't been written in a nice format. And our goal is to get rid of that x minus 1, okay? So step 1 is going to be performing the long division. Let's just try to perform the long division out there, x minus 1, and we get x squared plus x minus 1. And I'm going to multiply x right there so that we get x squared minus x. And you can vertically subtract these two to get 2x minus 1. All right, so what do I need to multiply to get rid of this pivot position? Well, 2 to x minus 1. So I'm going to multiply 2, positive 2. So if I multiply positive 2, it becomes 2 times x minus 2. And if you vertically subtract 2x and 2x, they're going to get canceled. We got negative 1 minus negative 2, which will be 1. All right, so let me use ... We got 1 out there. So what's the next option? Well, the next option is going to be x squared plus x minus 1 divided out by x minus 1 can be in fact written out as x plus 2 plus 1 over x minus 1. And if you use the AMGM inequality straight off from this expressions, well, I don't think that x plus 2 and x minus 1 will cancel. So we're going to do some variations, okay? We're going to approach with certain variation, and let me use this. Give me 1 second. All right, so let me use this. So how do I move this? Ooh, yes, there we go. All right, so if I arrange these expressions somehow nicely, I think I can change something about x plus 2, but I don't think I can change anything about the denominator. So our goal is to fix this denominator and probably use some number expressions on x plus 2 so that we can change it. And this is what's going to happen, okay? So we got x minus 1 plus 1 over x minus 1, and we can add it up by positive 3. And check this out. Well, the expressions that you see right there will get canceled off if you use the AMGM inequality accordingly. So that will be greater than or equal to 2 times square root of x minus 1 times 1 over x minus 1. And x is greater than 1, obviously, so it gets canceled, and we're left with positive 3, and that becomes 2 times square root of 1 plus 3. So 2 times square root of 1 plus 3, I can tell you that that's going to be 5. And, of course, this whole setup appears when x minus 1 equals 1 over x minus 1. So we got to understand when it comes out as the inequality switching into equality. Inequality will turn into equality if these two expressions are the same. So we end up getting x minus 1 squared, in fact, equaling 1 for sure. So x minus 1 is either positive 1 or negative 1. So x is either 2 or 0, but we have the assumption that x is positive already, so x is going to be 2 when this occurs. And the minimum value will be 5, and that shall be it.